Britespan manufactures most of the small parts required to assemble our buildings. Each part and subcomponent has its own production order, accompanied by a blueprint. Manufacturing drawings are produced by our engineering department to meet unique customer requirements. Quality checks are performed by the welder to ensure parts are produced to drawing specifications. Whether it's manual welding, using a fixture, or using the robot to complete the welding, quality is our #1 priority. There are many tools and processes in our facility that we use to make small parts. We bend all of our webbing in-house using a CNC-controlled tube bending machine. Operators program the parts using Bend Pro software to ensure our webbing will fit when arriving at the weld station for final processing. We are capable of processing tube up to 1.5 inches in diameter and 170 inches long in 90 seconds. We then clip the ends to prepare for welding using an iron worker. Production orders, along with blueprints, identify the part number to be produced, material to be used, and the operation to be performed. Britespan's cold saw is capable of processing pipe up to 4.5 inches in diameter and in lengths of up to 48 feet. Our drill press is used to process both round and square tube for leg manufacturing. Templates are used to ensure repeatability when operating the drill press. All parts produced are self-checked and then inspected by the quality technician before moving on to the final weld station. Our Epic and Genesis building series are built in one of 2 large welding cells. Welders work in tandem to tack and weld these large trusses. Due to the size of the subcomponents, we utilize a 3-ton and 5-ton crane to assist the welders placing the subcomponents and to maneuver the trusses during welding. Britespan's large buildings can span up to 300 feet wide. Once the part is fully welded, checks are made to ensure the part is made to exact specifications to guarantee ease of installing at its final destination. Our Davy roller is a key piece of equipment for our manufacturing team. The roller is capable of rolling pipe up to 4.5 inches in diameter and 1/4 inch thick. The roller is numerically controlled and programmed by the operator to produce the exact radius required to make each part. Once rolling of the parts is complete, parts are verified using our quality control table that can be set for all of production parts. All custom rolled parts are verified using templates or gauges made by our qualified welders prior to production. Whether it is subcomponents produced in-house or purchased at one of our approved suppliers, all of Britespan's parts pass through a receiving inspection prior to making their way to a weld station. Receiving inspections are outlined in our process control plan and include verification of all blueprint dimensions as well as quantity required to fill the order. Truss assemblies are done after every setup to verify that dimensions meet our structural drawings. Additional checks as defined in our process control plan are also completed depending on the length of our production run. Up to 4 assembled pieces are required to validate structural dimensions. All of our final product must go through a final inspection as described in our process control plan, including weld quality, before being shipped for either galvanizing or as a complete part to the customer. Our quality technician and supervisors are certified by the CWB for the Canadian markets, the AWS for the US markets, CE for the European markets, and JIS for the Japanese markets. Britespan builds a wide variety of parts in our welding cells. All subcomponents are verified by the welder to the production order and blueprints prior to starting a job. Each shift also inspects the prior shift's work to ensure compliance to blueprints. All structural weldments need to be done in a flat position. In the small building cells, this is done with assistance of a 1-ton crane. We use visual management boards to ensure all the administrative tools are available to the welder to complete the assigned task. This includes production orders, blueprints, weld procedures, lockout procedures, and production targets. All parts produced are identified with a part number for ease of identification and installation. In our truss stations, all jigs are either rotated manually or using a mechanically driven rotator. Once the welding is finished, the parts are cleaned and inspected by one of our operators. After the inspection is completed, the parts are bundled, according to procedure, to prevent damage during transportation and taken to the quality assurance area for final inspection. To ensure timely delivery at a moment's notice, Britespan stocks over $4 million of inventory at any time. Parts are assembled in fixtures by the welder, and then our robot tacks all the components into place. The robot then completes the final welding of the part. Parts are removed and inspected by the welder to ensure welds are complete and meet blueprint specifications. Our large robot can weld a variety of product in both our large building cells as well as a station for smaller components. Our Super Atlas is a popular model for building clear span widths up to 108 feet wide. Subcomponents are inspected prior to being fit into the fixture for tack welding. Once the components are tack welded, they are removed from the jig and final welding takes place with assistance of one of our large cranes. Once final welding is complete, parts are inspected for weld quality and critical dimensions. They are then staged for final inspection by our quality technician. Our bandsaw is used to cut subcomponents to length, as well as to cut our hollow structural sections, or HSS. Our HSS is hot-dipped galvanized prior to processing and is primarily used in our end walls. Our HSS comes in a range of sizes from 4 inches by 4 inches all the way up to 12 inches by 12 inches. Templates are used for the different hole configurations to ensure alignment in the field. Although most of our swaging is completed at our raw material suppliers, we do have the capability in-house to swage material. The swaging material reduces the diameter of the material so the parts fit together to make one long piece of continuous pipe. Our Whitney plasma punch table allows us to plasma cut and punch holes in 5-foot by 10-foot sheets of steel up to 1/2 inch thickness. The operator loads the program, confirms the proper dies are in place, and starts the program. Once all of the holes are punched and the first piece is cut, the operator verifies that the part meets specification before continuing to cut the rest of the sheet. All parts are received into the plant by the quality technician to review accuracy. The parts are then released to welders to be welded onto the final products. The purlin press operator verifies all material to the production order before being processed. The purlins are made in 2 stages. First, the pipe is flattened on both ends using hydraulic presses. Then holes are punched in each end using an iron worker. Purlins are used to provide support to our truss sections and are uniquely designed for each building. They can either be made from pre-galvanized or hot-dipped galvanized material depending on the application, and come in a variety of diameters and lengths. The plasma coper is a CNC cutting machine that cuts pipe to programmed profiles. We process subcomponents for our base rail foundation system, as well as all of our stick webbing used in our larger building series. The parts cleaner is used to remove mill scale, slag, and burrs from small parts. The cycle lasts about 5 minutes, and the parts can then be removed and inspected by the operator. The parts are now ready to be received by the quality technician and released to manufacturing for final assembly. Trusses are loaded and shipped by truck to the galvanizing facility. An important quality process for all of Britespan's steel trusses is that they are hot-dipped galvanized after all fabrication and welding are completed. Britespan's trusses are welded together. Then they are cleaned to remove any rust, impurities, and oil that can interfere with the galvanizing. The trusses are then dipped in the molten zinc tank where they are fully galvanized. When trusses are fabricated and welded after galvanizing, also known as pre-galvanized, the fabrication process will burn off the zinc coating on the inside of the tubes when the web is welded to the tubing. These sections never get re-protected, and the tubing will rust from the inside out. This quality standard is applied to all of Britespan's steel trusses. The material is received back from our galvanizing facility and is staged in preparation for the cleaning process. We follow a documented and standardized procedure. Posts are used to separate the pieces. All holes are inspected and checked to ensure that the trusses will properly assemble in the field. Holes with any debris are cleared. All mating surfaces need to be free of debris or contamination so that the trusses will fit together smoothly. Every piece is 100% inspected. Rough spots or contaminants on the outer cord are identified and marked. Then a pipe sander is used to smooth these identified areas. The trusses are bundled for shipping. They are bolted together, and wood spacers are inserted to prevent potential damage during transport. Once banded, a sticker is applied that certifies that the trusses have been 100% cleaned, inspected, and verified by the finishing supervisor and approved for final shipment by the distribution department.